Good morning and good afternoon for you guys in the Americas. Thank you for joining our webinar. We're on this side of the planet. It's already evening. My name is Liat. I'm the Chief Marketing Officer of Recognize, and I will be your host for today. I hope technology will be on our side, but if any technical issues emerge, you can't hear or see, please let me know in the chat, which is in the panel at the right corner of your screen. If you have any questions you'd like to ask in the Q&A session, which will be held towards the end of the webinar, please write them down in the panel where it says questions. We'll do our best to answer as many questions as time allows. With me today, my colleagues, Dr. Vahid Krupik, Global Sales and Business Development of Samgard at Samsung, who will be joining us from Samsung's headquarters in Frankfurt. Here with me in the Israeli-based office in Haifa, engineer Maya Rubin, and engineer Vladimir Brailov. So what do we mean by the devil is in the details? A plant is very much like an orchestra. There are many instruments and many players, and they must work well together for us to hear the beautiful music. However, when one chord goes wrong, or one string breaks, there will be an awful or just out of tune sound. Same goes for a plant. There are many equipment parts and many processes. It's enough for one valve to break or one sensor to go wrong to hurt the operational excellence and sometimes even cause a complete shutdown. In this webinar, our process specialist will walk you through a few use cases that show how small things matter, how you can get true and substantial value when addressing small issues ahead of time. But first, Vahid, the stage is yours to give us the bigger picture.
Thank you, Leah, and hello to everyone. So, yes, I would like to give a little brief overview and introduction about our human-enhanced machine learning software, SamGuard. It is at the forefront of the digital transformation and is something that is part of the Samsung Group's digital policy and strategy going forward into the information age, Industry 4, and so on. Samsung has been in the flow control business, providing valve technologies for 113 years, and there's 4,500 souls in the company and 76 subsidiaries. So it's a substantial worldwide organization. As part of its digital developments, Samsung found, recognized in Haifa, a truly unique and very well innovative organization that won the Tech Pioneer 2018 award by the World Economic Forum for its innovative AI technology, which they patented. The development team, as Leah mentioned, is in Haifa, Israel, and is, as I say, part of the Samsung organization. It's mostly focused on the process industries, such as chemicals, petrochemicals, refineries, oil and gas, pulp, paper, cement, pharma, mining, for example. And these are representative of where we do have currently running projects and experience, but this is not an exclusive list. And other process industries, of course, would be covered by the product. We are globally present, as I say, and these are a small indication of where we've got projects running currently. Some of our selected customers, as an example, are Wacker, Bazan, LG, Formosa, LCY, Titan, which I'll mention more about later, Mitsubishi Chemicals, Suzano, and many more. We have some selected partners such as Siemens, Osisoft, IMI, etc. So now a little bit more about the background of where we're coming from. This is a machine learning product, and we say ours is human-enhanced machine learning, and it has some differences to the standard methodology. The original basis of many machine learning products was to look at maintenance, savings of maintenance, predictive analytics, how this could help lengthen the lifespan of the plant, etc. But we have found that the value of increased production, far outweighs any issue related to maintenance. And of course, within the increased production is naturally the maintenance element included. So this is where we start from. and the focus is on more production. So how does this work? How do you do this? Well, as I say, machine learning is not a new thing, and many of the existing machine learning tools focus on a smaller number of key assets, such as compressors and so on, where they look upon this. The little light there shows a very penetrating directed beam of also looking at repeated known problems, optimization, trending, and so on. But where we come into it with our human-enhanced machine learning is to look for the unforeseen events, the things that happen that are uncontrolled, unknown locations, unknown effects, but nonetheless very real. And I think everybody is familiar with unforeseen things happening or to them. And this also can be for known problems with unknown causes. For example, if you manufacture batches, one afternoon one is a certain quality and the other afternoon not, but you do exactly the same things and you're unclear as to why. So SandGuard can help you track down these things that you are unaware of and help you with that. So, but then comes the question, is there any money in this? And the orchestration of 1,000 parts is the key to it all. We have here a picture of a plant, and as you can see, listed on left and right is not only the physical entities and material within the plant, it's also the structure and the processes of the plant are taken into account within our tool. And this is the value of it, and this is what gives the power. You have to look at everything, or you don't actually pick up the little events that can occur, because you don't know where they're going to come from. They can occur anywhere, and that's why you have to look at everything. So back to why we want to do it. Where is the money? Here is the reason for it. We have here a real example from a customer that shows a 2-month period of alerts and their estimation and description of the value. So what we have here is we have an opportunity to save between 142,000 and nearly 4 million. Now, naturally, it's not going to be the maximum, but it is definitely between the two, because these hitherto unforeseen events are very small things that nobody is used to looking for yet. And that is why it's very difficult to give a maximum value. I draw your attention to the column C. Here we've got two key cause types, part failure and bad center. The bad center is one of the small things that are very easy to fix and not expensive if you can find them in time. If you don't, you have huge potential risk. So, moving forward, there, thank you. So now, without further ado, I would like to pass you over to my colleagues, Vova and Maya, who will run through examples of how these small events are critical and very, very important to find. Thank you.
So, hi everyone, I'm Vova, short for Vladimir. I'm process engineer here at Recognize, and today I'll be showing you several real cases which were discovered in our clients. So first of all, I want to talk to you about how do we do it, okay? So first of all, we listen to every part of the orchestra that we just talked about. So we're checking, I mean, literally not us, but the software and of course the computer is checking every equipment, every tool of the orchestra, and it's checking each and everyone's behavior. How is everything is correlating between each other? Okay, so since we know the baselines ahead of time, we can the system is able to identify abnormal behavior in that type of from baseline. So looking at the first case right here, we're talking about a pesticide plant. This is actually a reaction vessel, a reactor. So in this case, system has produced an alert and is showing the user the following chart. Red tag right here is indicating the temperature, bottom temperature of the reactor, and the green tag is indicating the temperature measured at the middle of reactor. So yeah, looking at this chart right here, it's a bit hard to understand the issue itself. So what I'm trying to do is I will just zoom into this chart. So just a second. Just a second. So, yeah, we have some mouse technical problems. So wait a second, sorry. Okay, so right here we see the same chart. It's just that I separated it into two different. It's the same text from previously. Just we can see them isolated from each other. Right here we can see that the left chart, the red chart, there's a slow drift down since the beginning of April 2020. There's a drift down from the baseline it was before. Okay, we can see that right here there was a stable baseline right here until here, stop of the reactor, and after the stop we see a slow drift down in the bottom temperature. Well, at the same time, if we're looking at the middle temperature of the same reactor, it remained in the same baseline. Okay, so right now you have a reaction vessel. You have two temperature meters, and the one is actually drifting down. And if you can see the average value right here, it drifting slowly towards the ambient temperature below 100 degrees, and it continues to go down. So after the process engineer was able to observe this issue in this way, the immediate suspect was the valve that's controlling the reflux flow for this reactor. So, and the next, the closest maintenance stop, process engineer has ordered maintenance team to check this valve. And sure enough, while maintenance crew was checking the valve, they discovered that valve itself was leaking. Material from the reactor has leaked inside the valve, and it also obstructed the valve's movement. So, which caused inability to close the valve itself. And since this is a valve that's controlling the reflux flow for this reactor, it actually caused a problem in during the distillation steps of the process. Okay, and I want to just emphasize no other software is able to identify this kind of issue. So only SemGrid has alerted the user and inputted to this specific reactor and this valve. So after the fact, we know that for since there was a problem with reflux flow, the customer has used more than its usual usage of raw material for this reaction. So there was actual waste in raw material because it wasn't distilled in a proper way, and not enough raw material was returned to the reaction. Okay. Now I want to go to a second use case. Just a second. Sorry, same thing with a mouse, sorry. Okay. So now there's another case coming from a mining plant. Okay. This is a very unique case. So right here we can see the top chart. We can see in purple the pump's oil temperature. Okay. So I just want to, before talking about that, I just want to explain to you a bit about this mining process right here. So in this specific alert, we're talking about the main pump that's actually pumping the mine material back to home base for further distillation. Okay, so this is the main pump, and any type of inefficiency in this pump is not acceptable since it directly influences the production rate. So right here on the top chart, we can see a drift up in pump's oil temperature right here. And at the same time, if you're looking here, it happened just before May, just before 13th of May. There's a drop in sealant fluid pressure to the same pump. Okay. So first of all, I want to make clear that the process engineer from this plant has already seen this rise in pump's oil temperature. So other, let's say, other control system has alerted on this type of rise, but the process engineer and also myself included, just dismissed this alert as related to ambient temperature rise during the hot summer days, because you can see here it's you can argue that during April temperature is a bit lower than during middle of May and going towards August month. So, but once the process engineer was able to see our alert generated by SAMGuard, which correlated between all this sealant fluid pressure and sealant fluid outlet flow and pump's oil temperature all on the same chart, it was very clear that they have a serious issue pumping sealant fluid towards the main pump of this mining tool. So immediately after seeing this alert, the process engineer dispatched a maintenance team towards to check the pump. And what they've done is they actually discovered leakage. So the sealant fluid was leaking to the environment and not reaching the pump itself. Which of course over time it can damage the gear of the pump, and it can lead to gear replacement, which is very costly, and also to stopping the entire process of mining, which of course no one wants that. So we were able to, in this case, we were able to alert the user, alert our customer ahead of time. So before the pumps actually break, nothing broke. The customer just replaced the piping, and everything went back to normal. So this small issue may have an influence on the entire plant. So as we said before, one tool was having, let's say, an out-of-tune moment, and it can influence on the entire plant. Okay, and just a second. Yeah. Okay, so the third issue that I want to discuss with you is actually coming from a slightly different plant than previous slides. This is coming from a polymer plant. So in this case, we're talking about heat exchanger. As I said, in a polymer plant, we can see in orange tag, which is representing flow of cold side, and the bluish tag representing temperature of hot side. So you can see that there was a rise in temperature that was followed by rise in cold flow to the heat exchanger. And you can see that there was a very stable baseline from beginning of this is March, and up until this is like 17th of June. It was, you can see there was basically some kind of a stable baseline. And right here, you can see both of the flow and the temperature starts rising. So, and I must say that this issue is coming from a veteran customer. What I mean to say is that this customer already understands, and he deals with each alert very seriously, and he knows our software means business. So after seeing this type of alert, he immediately stopped the process and he ordered maintenance team to check this heat exchanger. And sure enough, that they found fouling inside the heat exchanger. They found actual coating inside the hot side, which damaged the efficiency of heat transfer between the sides. So in this case, after speaking to the client, it not only had an influence on the process itself, interfering with the proper work of this heat exchanger, but also it was told that it was also a safety hazard because the material itself was dangerous. So in this type of alert may even save lives, and nobody can put a price on that. It was very important alert and very very significant one. And that's it. So I want to thank you, and now Maya will take it from here.
Thank you, Vova. So hi everyone, my name is Maya. I'm also a process engineer together with Vova. Our first case that I would like to present you is talking about a steam generating process. Please take a look at the black and the yellow lines. Those are the flow and the temperature of the inlet cold side. As you can see, during all the period, they are stable. The flow is around 45 tons per hour, and the temperature is around 112 degrees. Now, let's take a closer look on the temperature, on the outlet temperature of the cold and the hot side. So as you can see on the left part of the screen, the temperatures are stable at the beginning. The hot side is around 155 degrees, and the cold side is 144 degrees. Now, on the event, standards tell us, look here, we have a shift up on the hot side and a shift down on the cold side. So that means that the efficiency of the heat exchanger is reducing. Now, I didn't mention it on the beginning, but we're talking about an economizer. Economizer, as you probably know, this is a heat exchanger that recovers heat from exhausted gases, and this is an energy for free. So any energy that we will not gain here, we will pay later with the gas consumption. So at the first, sorry. Okay. So at when I was talking to the process engineer about this case, so he told me that there is a job of 1 in 6 months to clean up this heat exchanger. But when we looked up when was the last time that this heat exchanger was maintained, so we saw that there has been more than 1 year since the last maintenance. So this is, if I can tell from my experience as a process engineer in the field, you have usually a lot of things that are scheduled very nicely on the Gantt, and you know that you have to do all kinds of jobs exactly at the right time. But in a matter of fact, on the everyday life on the field, you have so many surprises and so many action items that comes up. So many times things that looks like less important are postponed and sometimes even missed. So this is a benefit of SandGuard because it's like a wake-up call for you. It's like telling you, hey, you forgot this heat exchanger. Okay. Next case is about compressing a process. So in a compressing process, you have several stages. And we're talking here about the third stage, about the controlling valve. So as you can see, the brown tag is talking about the set point. The red is the PV and the purple is the OP. So as you can see, the set point and the PV remains stable all the time, but the OP is raising up, and we didn't understand why. So the first guess of the process engineer was that maybe the outlet flow of this vessel is increasing, but when we looked at the flow, so we saw that it is stable. The second guess was that maybe the filter is blocking, but also we checked and the delta P didn't have any significant change. So the last thing that we thought about is maybe this is the strainer. Maybe the strainer is getting blocked. Now there is no alarm on the strainer. There are no parameters that shows that it might be blocked. But also, again, we saw that there was a lot of time since the last time the strainer was cleaned. Now, this reminds me a metaphor that one customer of one old customer told us. Told me, and it was really nice. It was talking about how he looks, how he sees SandGuard. So when he talked about SandGuard, he said that he's thinking about a class. And in a class, you have all kinds of students. You have the noisy students that you pay attention to them. You know that they are noisy, that they can do problems, they can disturb the class. But what about the quiet pupils, students? Usually you don't pay attention to them because naturally most of your attention goes to those who are problematic, because we are subjective. And this is where Samgard comes in. Samgard is objective. He looks at everything, at all the plant, all across the plant, and all across the plant you have hundreds and maybe thousands of measurements. He doesn't care about who is the noisy one and who is the quiet one usually. He looks at the data objectively, and he sees all the history, the way that the tag is behaving normally, and if the new data shows abnormally, so he would alert about it. Next case is a stripper. Okay. Next case is about a stripper. The inlet flow into the stripper is the steam. So you can see here the red is the set point of the flow of the steam. The blue is the PV, and the OP and mode are in a sort of green. So as you can see, the PV and the OP are pretty stable, but when we have the alarm from SunGuard, you see that some disturbance has occurred here. When we talked to the control room, they told us that, oh, it's okay, and the steam is not stable today. So we just took a look at the source. The source is the let-down station from the middle pressure to the low pressure, and we wanted to see if everything goes well there. And then we found something very, very odd. Please take a look at the brown tag. This is the steam pressure, the low pressure that goes into the stripper. And the blue line is the temperature. So you can see that the pressure is remaining around 4 bar. It has a bit shift up, but mostly it's stable. But look now at the temperature. The temperature has a really dramatic decrease from 190 to around 140 degrees when we had the alert. Now this is something that is not explainable so easily. So we did an analysis and we saw 3 interesting things. First of all, the let-down station from middle pressure to low pressure was totally shattered. This is not something that was planned, and there were no alarm about it. So that was the first finding. Another finding that is really crucial is that the alarm on the temperature of the steam was set on the control room to 100 degrees. Now, if you think about it, 100 degrees in steam, it means that it already contains high amount of water, and high amount of water on piping causes hammering and could damage the piping. In addition, if steam like that will enter reboiler, for example, it could cause even a shutdown of the reboiler and a disturbance to the process. And the other thing that the third thing that we have found is this green line. The green line is the water spray on this let-down station. So as you can see, it seems like it's 0%, but we suspected that it might not be sealing. And if the valve is not sealing, it could cause a decrease in the temperature. So the action items for this case, for this really important case, was first of all to set 10% alarm on the control room for the let-down station. So if it closes, they will know next time. Also, the other action item was to set the temperature alert to 150 degrees. And the last one was, as I said, to check the valve. And when they checked the valve of the water spray, they saw that it's really not sealing. Okay, thank you very much. Waid, please.
Yeah. Thank you to Vova and Maya for the brilliant overview of how important small things can be. is this from our customer Titan, which I mentioned at the beginning of the webinar. The Titan is in the cement industry, and this shows the value of integrated and running SandGuard solution in the analytical monitoring concept at Titan. They have rolled this out through their global organization, and here it shows the value of the product. You had an increase of 10 percentage points in the reliability factor year on year, significant production gains, which for them are very important because they're in a sold-out market, and the repair and contract labor costs were decreased by 5 and 8% respectively, and a very substantial saving and addition to their profitability. And you can see here the efficiency increase over a 12-month period, rising over 99%, truly world-class. Very powerful tool. So how would we implement and do this in your facilities? The first stage would be to use the product on your own with our help to install the modeling and install it and work with you for the first 6 to 12 months to bring you to an understanding that the hitherto small things that it shows are very, very important and very valid. And there's a bit of a sort of cultural transformation that needs to occur here in any organization. And it's a paradigm change, and it challenges the business as usual way of working. The next stage, and this is what Titan have done, is to have the corporate analytical monitoring center, where we work with the customer to build an analytical monitoring center and install the product and show how this can be very powerful and bringing a holistic overview of the plant. And the particular customer now does all this work themselves in a very, very, very short order. Very, very powerful for them. The other way that this can be done is to do essentially the same thing, but we do it for you as a service. Our experts will work very closely with your people to address all maintenance issues and flag up what is happening. This has the benefit, it's minimal effort on your behalf of the plant team, but it's always best in some cases if you have enough facilities in one location or several similar things worldwide to do it within your own organization, where you have limited resources, we can of course provide you this service as well. So thank you, Layat.
Thank you.
Thank you. Over to you. Thanks very much.
Thank you. And we'll see what questions do we have. So we have a couple here, and let me begin with the first one. It says here you introduced customers of various verticals. Isn't it important to own the knowledge of a specific plant or at least a specific industry?
No, what we require is the tool basically needs 12 to 15 months of stored data. What we need is something that is complex and changes over time. Because we are looking for the complexity is very important, that we gather all these orchestrated parts, as Layat mentioned earlier. We showed the processes, the structure, and the assets. That is how this works. That's how you get the value from it.
Thank you. One of the questions here asks for examples of the cement plant. I refer you to our YouTube channel and to our website, where we have an entire webinar dedicated to cement plant use cases. So it's www.precog.co and webinars. Under webinars, you can find the last webinar was dedicated to cement use cases. Okay. Another question. You said implementation, and could you elaborate and say why is it important to have an analytical center in a plant, and how is it weaved into the workflow of plant operational team?
Yeah, sure. The implementation of the tool is very straightforward, and typically it's a 2-week process to model everything using our SandGuard suite. Quite an intuitive process. And for a 10,000 historian tag plant, we typically take 2,000 to 3,000 tags into the system, and this, as I say, takes about 2 weeks. Using the Analytical Monitoring Center is a very nice package. And what happens often within the installation in the first period is that it takes, as I mentioned, it's a paradigm change. And I think anybody running a business and wanting to do digital transformation finds that the biggest challenge is actually to get people to accept and use this in a new way. It's challenging the normality. And the Analytical Monitoring Center helps get over this by installing a feature with dedicated staff working to use the tool in a focused way, and then helping the colleagues to search for and deal with the problems. It humanizes it and helps the transformation process. And also, as I say, if you've got a large plant with numerous elements, you can have this all centrally looked at from one point, makes it much more efficient. Or indeed, if you have a number of similar plants distributed around the world, you can centrally monitor them too, keeping a lot more focus and centralization over the operation.
Thank you. One of the attendees asked about the data collected. Data collected in the processes, where is it saved? Is it saved in the cloud or in the solution itself, the software itself?
Okay, that's a very good question. This goes to the core of how many process industry customers wish to handle their data. What is typical is that we require the data to be stored in some location. It's typically in a historian, and we do not interact with the plant control system at all. This is just a one way. We get the data given from the historian. This can run on the plant systems. We need a Linux machine. It can also run on the cloud if the customer so wishes. But we find that many people in the process industry are very sensitive to data and its location and use. And we definitely can run on the plant if that's the way the customer wants. And it's an extraction from the historian.
Thank you. One of our listeners asked about the historical data compared to the data we collect.
Okay.
What do we do about new equipment?
Yeah, that's a good question. Now, this is obviously one of simple logic. If we take the historical data over the 12 to 15 months, this we need to train the engine of the machine learning. Going forward, if you change the process or you change the fabric of the structure of the plant, naturally there has to be a time where the software requires the new data sets in order for it to be operational. And this typically requires about 6 months of data for that to happen. But the software does learn over time as well. Smaller changes are incorporated, and it updates itself actually weekly, usually on a Sunday.
Okay, we'll take a couple of more questions. One asks about the difference you mentioned about repeating and non-repeating problems. Why is it important to differentiate between them? Do they require a different solution or like a repeated solution?
Well, yeah, that's a very good, again, another good question. If you have a problem repeating itself constantly, and you are going to find that, and you are going to want to know in great detail why that's occurring. And this is why there's lots of machine learning tools out there that do deep dive into limited numbers of assets. Well, the unforeseen, out of the blue, act of God events that occur are not in this direction. These are things that are totally unlikely to happen more than once in any given time frame. And when people ask, what is that? I mean, if you've got a room of people for an absolute identical thing to happen in a plant that isn't on a critical event that you have already dealt with, it's going to be our lifetimes are going to run before you see another absolute identical one. And that's why you need to take everything into account to look for these unforeseen things. If you know exactly where a problem is going to occur, that's a completely different type of event.
Thank you. Another question refers to you mentioning monitoring the entire plant and the importance, and also the analogy to an orchestra. It would have made sense to monitor one specific asset or something that gives you a lot of trouble. So could you explain again why it's important to monitor the entire plant?
Yeah. If you have a very, very important asset, take for example a compressor, and you are critical here, you may even have a backup available. You know exactly that's very important, and you have a very key focus on that, and you want to know as much as possible about that compressor as you can. This is a key focus. The reason we monitor everything is because it's for the unconnected, unlooked for things that happen that cause immense problems. You can use a music analogy, which we have done, in the fact that it's an orchestra that is, if you have a bad violin, you're going to hear it. You can also use a medical analogy. If you present yourself to a doctor with a bad back, that bad back could be a multiple of different reasons. You could have no end of different things wrong with you that present themselves as a bad back, and that's why the doctor has to ask you lots of questions. It's in regard to these things that happen that you can't predict. You don't know where it's going to be. That's why you look at everything.
Thank you. Regarding the equipment and the sensors that are used to collect the data, can it be from any manufacturer or only from partners?
Sorry, could you repeat that? From any or from what? I didn't get you there.
The data collected, can you hear me?
Yeah. Well, what was the question? Could you repeat, please?
Yes. The data collected, can it be collected from all kinds of equipment, all kinds of sensor, or does it have to be from specific manufacturers, only partners?
It can be collected from absolutely anything that produces a signal that can be collected. As I say, it has to be collected and stored in a way. It can be anything. It could even be Excel that store it. Typically, chemical or indeed any other process industry plant would have a historian which stores the data. So we can take absolutely anything, and more the merrier, as I say. Absolutely.
Okay. What can be done to identify problems in control valves, like final control element and pumps, like control valve and pumps?
Well, obviously these two components produce data that is, or tags that are collected. But it's what we do, we don't focus on specifics because we are looking for the interconnections around everything that show events occurring. It could be, for example, in a valve will fail because of blockages, or it could be due to wear of things going through, elevated temperatures and so on. But that's the consequence of something else occurring. It could be a bad temperature sensor or a bad flow meter that's not giving the right readings that would then lead to the failure of the valve or the pump. And this is what the power of our solution is. It actually finds the thing that's causing something to go wrong. And a lot of people are looking at the event that occurred to the critical item without considering the reason why that item failed, because they don't look in the wider sense around that item.
Thank you. Thank you very much, Vahid. Thank you, Maya. Thank you, Vova. I urge you guys to visit our website. There's plenty of material there, more webinars, and also any questions that you didn't get the chance to ask now, you're more than welcome to send to info@precog.co, and we'll be more than happy to address them. Thank you very much and have a great rest of the day. Bye-bye.